Okay. This is one heck of a chapter, and I'm not going to be able to, you know, go over it piece by piece with you because there's way too much. But I will highlight what I think is important. And this opening vignette is one of my flashbulb memories. Flashbulb memories are, events that happen in your life that uh, cameras used to use flashbulbs where it's like you feel as if the memory is burned in, and that's Princess Diana's limousine. And when that started, I was sitting at my computer, as I always am, roughly two houses ago, and heard about the accident and did not have a good feeling. Uh, and sadly, I was right. I believe this was a Mercedes, one of the safest cars on the road. In the front, you can see pretty much a wedge because this car went straight into a support pillar uh, in the road in an underpass. And they talked about it being in a chase. The chase was with photographers who were trying to keep up with the car and take pictures of the princess. Um, So yeah, it was a chase, and the blood alcohol level of the driver was well above the legal limit. Uh, it it was quite a crash, and that's discussed over here. There's his blood alcohol level, and I've seen videos and photographs of him prior to the accident. You would never be able to look at him and identify him as being drunk at that time. He was a chronic heavy drinker, as it says here, and no doubt he had a lot of behavioral tolerance to this. And alcohol almost certainly played a role in the accident. Uh, yeah. Okay. So there's a nice history of alcohol here, and I've given you on the page that led up to this. Um, oops, we're doing. Yes, I don't have this lecture link yet, but that how beer saved the world. Some elements of the the story that's in that fairly serious documentary, but it's humorous, are in this chapter, and you will have to pay to see it. I have apparently bought it, so I don't have to pay for it anymore. It's an interesting story. It combines history and chemistry and behavior. I like it a lot. So, you're busy with the class. Don't look at it now, but someday you might take a look at that um, video. So, we've had alcohol for a long time. It develops kind of automatically, as the movie shows nicely. Yeast is important, and we're breathing in yeast all the time. So, accidental fermentation is almost a certainty. And so being able to produce alcohol uh, had to happen and did. And some argue it was more important than bread in terms of the development of systematic farming civilizations. I can't speak to that, but it's an interesting story. And there's a discussion of Rome and wine. Uh, Rome, well, they already had a lot of lead in their system. They were delivering their water, often using lead pipes. But to improve the taste and richness of red wine, they would often add a powdered substance that had lead in it, and that's not good. Aqua vitae, that's a nice term, water of life. That's distillation, wine into brandy, and then enter the Dutch and gin, and that's an interesting story. And there's very, spend some time looking at the picture, figure 10.1, Gin Lane. Uh, this is what rich folk thought of poor folk. Um, Distilled alcohol, gin, was for the lower classes originally, and it's not quite like having the ability to IV your heroin, but you're moving in that direction. It's very concentrated and can affect you very aggressively. And as I said in the earlier chapter on addiction, if you want to get addicted to something, you want something to hit you hard. And distilled alcohol is much better than that. And we have developed a culture in this country for college students, my friends, that virtually is designed to increase binge drinking and certain types of alcoholism. And it's not good for society, and it's not good for you. Um, and some people learn that doing shots gets you messed up very quickly. Yeah, so does heroin going into a vein. So the interesting discussion here is that the gin is for the poor folk, and the more genteel people were drinking beer. And a little bit later in the chapter, where they'll talk about alcohol taxes, trying to, in effect, shift people away from distilled alcohols, which are too easy to shoot and get messed up on, to kinder, gentler alcohols like beer, and it possibly can work. And then, there's a discussion of the failed experiment of prohibition. And as I think I've already alluded to, one of the best things that ever happened to organized crime. Um, Tonics, lots of alcohol. Uh, we had it, it went away. It's an interesting story. There's the chemical structure of methyl, ethyl, and isopropyl alcohol. You only want to drink one of them. And you can see that structurally they're pretty similar, particularly methyl and ethyl. And if you're doing distillation and you don't know what you're doing, you can produce alcohol with a lot of methyl in it. And that can kill you, it can blind you. There's a delightful British comedy, Doc Martin, and in one of the episodes, people were being poisoned by alcohol and couldn't figure out what it was. And it was, a local poor person trying to make some extra money by distilling alcohol, but he didn't know what he was doing. Spoiler alert. And he was distributing alcohol with methyl. And the dramatic scene in the movie is Doc Martin realizes that somebody has consumed the tainted alcohol, and he's driving out in the hinterlands, and he's in trouble. And he goes and grabs him, and he's out of it. And to treat him, they literally break into a pub and force him to drink ethyl alcohol, which competes with the methyl and can protect you. And then the ambulance got there and they took him to a hospital, and everything ended up okay. So home homebrewed beer and wine, you don't have this concern with. But with distillation, you better be sure that people know what they're doing. There's a television program about people in the South distilling alcohol, and it just freaks me out to look at it. Too many ways for that to go wrong. The discussion of proof is interesting. Um, you should know that the relationship between proof and percent. 100% alcohol is 200 proof, and I've tasted it. And you wouldn't drink it for fun. Well, for twisted, dangerous fun, but not because of taste. 100% alcohol doesn't even taste wet. It tastes furry. It's 100% alcohol. There's no water in there. And what we consume is, proofs comfortably below 100% proof and therefore below 50% alcohol. Very interesting story about the Brits and gunpowder and proof. You should know that. Blood alcohol content, and there's equivalencies: 5 ounces of wine, 12 ounces of beer, 1.5 ounces, which is a normal shot of hard liquor, 12 ounces of wine cooler, which is a lot like beer, and they're all equivalent. And you should know what you're drinking when you're drinking. And absorption in the GI tract, and um, different oral doses across time. Drinking with an empty stomach has a huge effect on how rapidly alcohol is absorbed. There's a lot of variables that can mess with this. How big you are, your sex, whether you've eaten, whether you've taken aspirin. There's, as the book discusses, there's lots that can affect how much alcohol gets into you. There's the metabolism of alcohol, and there will be questions on that at the end of the chapter. And then there's some of the genetics on this, um, and whether or not you can metabolize alcohol well. And when you have you're homozygous for the active form of the enzyme, uh, most Europeans are this way, as the movie points out, that ethanol helped us survive the stupidity of not knowing how bad it was for poop to get in drinking water. We had no idea where disease came from, but alcohol very often destroys what was bad in the water to begin with. And Asians took a different tack, and they boiled their water, and they drank tea, and therefore they didn't have to worry about metabolizing alcohol as much as Europeans, and that's all discussed in there. Um, Aldehyde hydrogenase, and there's the Japanese, Korean, Chinese. That's all. And these things will become, some of this will come up later in terms of the genetics of addiction. This table, I used to have it in my wallet. It comes from the great state of Pennsylvania, I believe. Yes, source Pennsylvania Liquor Control Board, 1995. And there you go. And you have males and females and different body weights and different drinks. And of course, time is another variable. Um, know what you're doing. Um, Tolerance, behavioral tolerance, metabolic tolerance. There's acute, there's longer lasting. Talk, behavior, yes. Classical conditioning. Now, I'm going to resist giving you that lecture, I hope. But I also have a little table for you there. And it's important for addiction. It's important for understanding pharmacology in general. Uh, it's not life and death. I'm not going to give the lecture. I'm not going to give the lecture. But yeah, you have a rudimentary understanding, Bell meat powder, and the Bell doesn't cause you to salivate at first, but eventually it does. And that's relevant to that discussion. Hangovers. We're still trying to figure out what the heck a hangover is. And as the book reflects, we aren't so clear with where they come from. I've never seen delirium tremens. Apparently, I had a relative who went through it, and it's something it would probably make you think of demonic possession as epilepsy can, which it is an epilepsy, but it has some related uh, characteristics. Um, what does alcohol affect? It doesn't miss much, and it's a carcinogen. Uh, it it's a carcinogen because it can kill cells and they have to grow back, and that increases the likelihood that a cancer will start. Um, and then pharmacology in action. The book seems to like, oh, a 2x2 table, how exciting! Which I won't talk about, but it talks about sexual responses and placebos, which is very interesting. And notice that your columns have tonic water and ethanol in terms of what you get. Now, of course, the ethanol is not ethanol, it's ethanol in tonic water, like a vodka tonic. Tonic, by the way, uh, can have a psychological effect all by itself. So, tonic based drinks may affect you more than a non tonic based drink. And of course, the history of tonic comes from malaria and trying to have the British go and oppress people where there was malaria, and they would drink gin and tonics, and the gin often had some stuff in it that might be of value, but the tonic would have some too. So that's they get tonic or tonic and ethanol, and they expect tonic or tonic and ethanol and 2x2 table, and it's a nice discussion. I know I just skipped some of the stuff up top. Um, Self-fulfilling prophecy. Speaking of psychology, yeah, this is an important thing in psychology. It's finding what you expect, uh, and you're looking for fluffy bunnies in clouds. You see fluffy bunnies. You look for something else in clouds. You see something else. And this can seem funny, but when teachers are expecting people to be stupid or smart, they confine people as being smarter or stupider based on their expectations. And the same thing about ethnic biasing. So it's kind of cute. It's important. Scientists do this and make mistakes, but it can, in certain contexts, it can be extremely destructive. Um, oh, my system has stopped. There we go. Moving. Um, sex. And there's the issue about risk taking. And here's a discussion of correlation and causation, that if two things are associated, does that mean alcohol makes you take chances when you drink? Or does it mean that people who take chances drink alcohol and take chances? But on the right side of this page, there's some interesting data. So when compared with states where no change in alcohol tax, they found that after the 50% increase in the tax in Maryland in 2011, gonorrhea rates decreased by 24% in the 1.5-year study period. That's something. Um, we'll see that alcohol is interacting with neurotransmitter systems that are important for memory, and there's a discussion of blackouts, motor problems. And as soon as you see motor in my mind, I'm putting rats and mice on rotorods to see how long they can work. There's other ways of checking motor behavior as well. A lot of the things we've done before come up in this chapter, which is good because in not too long we'll have a comprehensive final. Um, so, do you think that alcohol consumption and traffic accidents is a myth? Uh, I would argue not. And so there's a mapping. by days, very nice rhythm. And gee, look at the alcohol related accidents on weekends. Go figure. Um, Traffic accidents, 18 to 24, very dangerous age range to drink and drive. For one thing, your frontal lobes, which I'm a big fan of, even if you haven't been exposed to lead, they're not fully developed yet. Your frontal lobes are not going to fully kick in, particularly if you're a male, until you're in your mid 20s. You combine already not functional prefrontal lobes or frontal lobes with alcohol and cars, and trouble ensues. Binge drinking, again, you want to develop a lifelong problem with drinking. Do shots. That's a great plan. And there's a little table. Thiamine. What's thiamine important for? Brain glucose metabolism. Gee, is that important? Well, glucose is the number one source of energy in the brain. So you're low on thiamine and you have trouble metabolizing glucose. Metabolically active parts of your brain are the ones that are going to be damaged first. And when you see this name, WERN, it's a German name, really German. So we go out and on 4th of July, we may grill on what we call a Weber grill, WEBER. But if that were a German grill in Germany, it would be a Weber grill. And it's not Wernicke, it's Wernicke. And Wernicke encephalopathy, confusion, disorientation, coordination, tremors, weakness, ataxia, uh, it's bad. And it results from lesions in the PAG. And we know I love the PAG. That's where my dorsal and ventral stimulation sites are, the medial thalamus, and the mammillary bodies. And I'm going to go a little bit further, and then I have some supplemental things to get to. Korsakoff syndrome. A high proportion of patients who survive Wernicke's encephalopathy, they get Korsakoff syndrome and potentially irreversible memory loss, inability to form memories from experiences, which leads to anterograde amnesia. You can't remember the future. The future didn't happen yet. I know. But what's happening now in 5 minutes, you can't remember it. That's anterograde amnesia. If you can't remember what happened last week because I hit you in the head, that's retrograde amnesia. So Korsakoff syndrome is anterograde. You can't form new memories. This is also what happens when you destroy your hippocampus with the toxins from filter feeders like mussels. Okay, confabulation. That's a good one. And some people with progressive dementia do this who don't have this particular type, but they create false memories. And what are their false memories about? Well, they can't find their wallet. They can't find their keys. They just put down a glass of water and they can't find it. And what are their confabulations? Someone is moving my water. Someone is stealing things. I used to have something and now it's gone. And these confabulations are often well articulated and they make sense, face validity. And sometimes it takes a while for the family to recognize that the person is making things up to not, they're not trying to cover that they can't remember. Their brain automatically does this. It's not malicious. They're not trying to get anyone in trouble. It's what people with these syndromes do, and it can be really disruptive to the family. Okay, and there's feeding thiamine deficient to animals, and enlarged ventricles and frontal lobes are most affected, and that's bad. Okay, so let me show you two things here. One is the PAPEZ circuit, which looks like PEPEZ, which is what I said for several decades, but it's apparently PAPES. And it's a circuit, which means it goes round and round. I electrified my bird feeder at home, and a lot of people are wondering, oh my God, you're shocking birds. No, you're not, because to get shocked, you have to complete the circuit. And the bird feeder is electrified, but unless you're a human or a bear who I'm trying to shock, and you're standing on Earth, which is the other part of the circuit, you don't get shocked. And so for this circuit to work, it has to go round and round. And exactly what it does, we're still working on it. But boy, there's some important parts in here. Notice the hippocampus underneath the word subiculum goes through the fornix to the mammillary bodies. And the mammillary bodies are how we got here. These are structures that are affected in Korsakoff syndrome, and they are part of the hypothalamus. And I'll show you where they are later. But the fornix carries information from the hippocampus to the mammillary bodies, and we know the hippocampus is important for memory. Then the mammillary bodies send information to anterior thalamic nuclei, which tend to be medial, and that was mentioned in the text. And then they send information to the cingulate cortex, and that has come up a couple times in the book. That's very important for planning, for example. And then the cingulate cortex projects back to the parahippocampal region, which is near the hippocampus. And oh my God, we're back in the hippocampus. So it's a circuit. It's the PAPES circuit. And if you destroy the mammillary bodies, that circuit can't go round and round, and things don't work very well. Now, up above here, there's a picture that's a little more anatomically correct. I'm not going to test on this. I just want you to understand the book more. There's our friends, the mammillary bodies, which we're interested in. Here's the hippocampus here, which make you think of bananas. And there's the fornix going up and around and back, forming a letter C, to the mammillary, then the mammillary to the anterior thalamus to the cingulate back to entorhinal cortex, and then finally back to the hippocampus. Now, how bad is this, Johnny? It's bad. There you go, my friends. This is a cross section through a human brain, unstained, and these two chewed up areas here. Those are your left and right mammillary bodies. Remember, most structures in the brain, cingulate, fornix, mammillary bodies. We'll be talking about the VTA again, and the nucleus accumbens, core and shell this time. There's always left and right. And there they are, the left and right mammillary bodies. They're very close to each other, but they're still left and right. And you let them get to that state, and there's no coming back. And you have profound disruption of memory. Here's a brain that has not been ripped asunder, and the mammillary bodies are. There's another picture. This one also. There's the left one. There's the right one. That's normal. There's absolutely no problems there. The state of Maine, when I went to graduate school, they were seriously talking about taking cheap wines and fortifying them with thiamine, so that people who were alcoholics and drank cheap wine would not get Korsakoff syndrome. You don't have to be poor, however, and drink cheap wine for this to happen. When you're affluent and you get most of your calories from alcohol, your diet is messed up one way or the other, and the alcohol is disrupting, and particularly if you're older, disrupting the absorption of thiamine, and you can get Korsakoffs and be quite wealthy. The good news is if you see this coming and you get people aggressively supplemented with thiamine, you can stop it and somewhat reverse it. So this isn't something you look at and forget. This is something you may save somebody someday because of this particular lecture. And look at the ventricles in this, how enlarged they are, how the cortical tissue is, or the brain tissue is reduced. A lot of that can be reversed by not all of it, by stopping drinking. And more on sex, and it's not good for sex. Um, and there's fatty liver on the next page is really disturbing pictures of livers and alcohol-induced hepatitis and cirrhosis. Ugh, bad, bad, bad. Oh my God, it's so painful. Um, you don't want it. You do not want that. And fetal alcohol syndrome. There's a powerful quote. Fetal alcohol exposure is the most common preventable cause of intellectual disability in the United States. Uh, Society has to worry about this, just has to. It is our moral obligation to worry about it. Plus, if all you care about is money, these people are going to cost us money, and they may have a little trouble with frontal lobes and impulse control. And on the next page, no, we'll get to it in a second. So there's a list of bad things that happen. It's bad. And there's a discussion of animal research, and we can prove this at least with high doses experimentally. Low to moderate doses, okay, there's some debate about how bad it is, but I was giving a lecture once because somebody got sick, and I had a substitute, and I was not very into developmental neurobiology, but I had to do it. And the number of neurons that you are producing in your brain at certain points of embryological development is astonishing. And you mix alcohol into that for a night even, I wouldn't do it. I just wouldn't do it. Um, I'm sorry, there's a picture. So earlier we talked about two different kinds of electron microscopes, the scanning and the transmission. Scanning is what you see here. It looks three-dimensional. So they've taken those rat pups and they powdered them with like gold, and they scan them. And it takes a while to look at it and see it, but there are some structural changes to the face, and that's in part my research. I'm not into fetal alcohol syndrome, but I'm interested in the development of the face. And there's a happy fetal alcohol child. Um, Sad, 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 sad. Okay, so boy, we're not getting through much here. And so I have to roll neurochemical animal models. There's lots of talk. Things that we've seen before are reintroduced here again. Um, Hopefully, you're recognizing things as they occur again. Um, and there's discussions of way we can look at things, and this parallels earlier chapters, so you shouldn't have any trouble um, following some of this. And that discussion there, alcohol preferring rats, genetically bred. Uh, Genes are important, and there's knockouts that we've seen before. And, um, you know, you've seen all these techniques used before, so we won't go over them again. Multiple neurotransmitters, that's an understatement. And here's why, in part, it's an understatement. Alcohol affects virtually all neurotransmitter systems, but the acute effects, particularly with moderate to low doses, are only a few. So those are the ones that are concentrated on. That figure is pretty telling. Um, One, non-specific, messes with lipid parts of the bilipid membrane. Two, non-specific, polar bilipid membrane. Um, Geez, non-specific disrupts relationship of the protein in the membrane. And then finally, you get specific axon neurotransmitter binding site, and also specific modifies gates, and specific interacts with the channel protein. And then those are all on an ionotropic receptor, and then there's a metabotropic receptor where specific simulates G5, which is linked to adenyl cyclase. So lots of there. Oh, look at that. Greatest effect is on the NMDA receptor, which we saw a lot of in the GABA chapter. Inhibits glutamate, and glutamate is the primary excitatory neurotransmitter of the brain. And we're going to see that it's also going to mess with GABA. So it's messing with the yin and the yang of the brain. And of course, there's a discussion not only of the acute effects, but withdrawal, and glutamate is affected in both, and NMDA is affected, NMDA receptors are affected in both. And here's GABA, major inhibitory neurotransmitter. We've already seen that. And GABA A are very important. And this is interesting. Extrasynaptic receptors respond in a more persistent way to GABA that remains in the extracellular space to produce tonic inhibition. Because they are more sensitive to the effects of alcohol, these extrasynaptic receptors are more likely to have a role in the behavioral and subjective effects produced by low or moderate amounts of drinking. So it's not that it doesn't affect the receptor complex directly, but glial cells are becoming more and more important in this whole story, and seems to be important for low to moderate effects of alcohol on GABA. Then there's reinforcing, and GABA enhancing, which of course you enhance GABA, which is inhibitory. That's going to be pretty much like inhibiting glutamate. And then there's also, so when you talk about GABA A, you're talking about chloride ions. GABA B, you're talking about potassium channels. And we've discussed both of those before. It seems appropriate once again mention that neuronal excitability is caused by a balance between excitation and inhibition, since GABA neurons frequently have glutamate receptors, and GABA frequently modulates glutamate release. The compensatory changes in each neurotransmitter may affect the other, the yin and the yang. And here's our friend dopamine and VTA and nucleus accumbens. And here the book begins to talk more about core and shell. Shell is there it is right there. Nucleus accumbens, particularly important because part of it, the shell, belongs to a network of structures called the extended amygdala, which is important to many behaviors. And they've been showing you pictures of nucleus accumbens in rat brains throughout the book. For reasons I can't explain, they switch to a human brain, but it's a good picture. And there's mesolimbic pathways, most drugs of abuse. I know I'm going fast here, but I really can't do all this content. And the book does a beautiful job. I just want to touch on most things. 6-OHDA, remember that's a neurotoxin. Almost total destruction of mesolimbic terminals with 6-OHDA does not abolish self-administration of alcohol. Therefore, suggesting that other dopamine-independent mechanisms may be important. And look, opioids, my personal favorite, because I used to do pain inhibition, a family of neuropeptides called endorphins that have opiate-like effects. I love it. They said opiate, later they'll say opioid, but right, opioids. And they are very important, so you can guess that in almost no time we're going to see naloxone, there we go, opioid receptor antagonists like naloxone and naltrexone, which compete for opioid receptors, primarily mu. And let me say this about that. Naloxone and naltrexone work really fast, within a minute or two. But naloxone wears off in about an hour and a half. Naltrexone hangs in there for a very long time. It has a much longer half-life. Uh, so there are people walking around on oral naltrexone where they are being treated as recovering alcoholics by taking systemic uh, uh, loading doses of naltrexone, and it seems to help. And there's a discussion of mu and kappa is important here too, and there's different drugs that affect kappa. And frontal cortex comes up again with craving scores, and opioids are involved in that, not opiates, because it's your brain's own neurotransmitter system. And then here's a category of other neurotransmitters, and they just blow through those. And on this page, you have the ones we've already discussed. And you would think we are almost done, but we are not. Then alcohol use disorder, and DSM-5 comes up again. And this definition has been evolving, and this is what the focus of the rest of the chapter is on. And are there subtypes? Are there different kinds of alcohol use disorder people? And in my day, we talked about type 1 and type 2, but that has largely been replaced by type A and type B. So different. But that table looks very familiar to me as a type 1, type 2 student from long ago. Age of onset is very important. And that's worth looking at and thinking about, and it is important in terms of treatment and etiology. And hi, I'm an alcoholic. Can you recognize me? Binge drinkers, and there's the sobering table, which was not intended to be a joke, but I guess it is a little bit. What causes it? And now we're getting into a discussion a lot like addiction. It's not one thing, it's many things. They interplay. It's you, your genes. Epigenetics are important. The effects of your alcohol consumption in the past are important, and your society and support structures. It's big. And you can bet that when uh, the cognitive behavioral therapy comes up, I'll be pointing that out again. So there's a vulnerability model, and there's corticotropin releasing factor and adrenocorticotropic hormone. CRF and ACTH are important. There's a word that I haven't used in the text. It's kindling. And if you ever started the fire, you start with kindling. Because if you try to light the log with a match, it's not happening. So you use kindling, and you light the kindling, and then you put on more kindling, and then bigger sticks and bigger sticks, so things can build. And that's a nice discussion. Uh, Anxiety is huge at the end of this chapter. Whoops, may hit it twice. Then we're dealing with risk factors again, and there's different approaches. And the term meta-analysis, I'm not sure that was mentioned before, but if I do a study and I publish my study, that's a study, and then you do a study and you publish your study, and that's a study. Well, some people specialize in doing a meta-analysis, and what they do is they go through the literature and they find all of our studies, and they go into our studies and um, they look at what we did and what we found. And if we published appropriate data, they can extract without asking us, because we're supposed to report this in our papers. They can extract how many subjects we had and how big the effect was and what was the probability of the p-value, which hasn't been discussed here yet either. But you can extract significance effects, and then you can do a meta-analysis. That is, you combine all of other people's studies into one giant study that basically asks the same question that everybody else asked, and you hope that the meta-analysis reveals wisdom, uh, because it is the study of studies, and it's an important research tool, um, that we never teach our students how to do at the undergraduate level. I had one student in graduate school who became a specialist in meta-analysis, and that served her well. Um, so, what are they finding? They're finding lots of things. And, ooh, look, a 5-HT transporter, that's serotonin. And that seems to be important. We've seen serotonin before. Um, and genome wide uh, association analyses, those were just discussed in the last chapter, I believe. And then we have rodent models, and originally rodent models were rats, but now that we're doing more genetic things, they tend to be mice. And here's sociocultural. And I have to find the reference. Years ago, I used to teach my students that it's a Western culture, but in this culture, it is unacceptable for people to act like they're stupid when they're drunk. It's just not tolerated. And in the United States, it's often celebrated. Uh, and when you look at those two cultures, uh, they act appropriately. And uh, we had a student come over here from Italy to visit her cousin, and we thought, well, she's 20 or something, she should want to hang out with the students in the hill, go to parties in the hill with students. She came back from one party in the hill with our students, and she was traumatized. She, promise you'll never send me back into that environment again. And then we were at dinner, and she was upset because she couldn't have a glass of wine with dinner. She had a little trouble adapting to our system. And the kind of drinking that college students tend to engage in is destructive, acutely destructive and chronically destructive. It's like we're building a drinking pattern to encourage inappropriate drinking. It's insanity. Um, it's insanity. And then there's a discussion of rehabilitation and psychosocial. And of course, we're going to come up fairly soon. We'll run into the 12 steps. I'm not a huge fan. There we go. I'm not a huge fan of the 12 steps, but there's cognitive behavioral. I'm a huge fan of that. No matter what you're dealing with in life, that is worth knowing how to do. And then there's pharmacological approaches, and there's lots of drugs mentioned here, antabuse, and there's my friend naltrexone. And naltrexone, remember, works just like naloxone. It blocks the same receptor site. It works just as quickly, but it hangs in there. You would be hard pressed to take naloxone all day and remain consistently protected from opiates or alcohol. But you take naltrexone all day, you can do it. And it's not magical on alcohol, but it definitely has benefits. And there's a nice study, naltrexone and treatment of AUD, and it's better. It's better. And it's a very safe drug, very safe. Um, There's naltrexone reduced the reinstatement of alcohol consumption triggered by priming injections of ethanol or ethanol associated cues. That's animal research, but that's also learning theory and classical conditioning and reinstatement of behavior that we thought we got rid of, which is related to relapse. Okay, there are different receptors for opioids. Mu is the one I concentrate on because that's very important for their effects on pain inhibition. But kappa is important too, and there it is in this chapter, kappa and mu. These results suggest that the mu receptor mediates acute reinforcing effects, as shown by the ability to reduce alcohol self-administration with mu antagonists. Antagonists at kappa receptors reduce withdrawal-induced increase in consumption only if dependent animals, only in dependent animals, suggesting that kappa receptors have a role in the development of alcohol dependence and withdrawal. So they're both important if you're already in trouble, but if you're trying to understand the reward property of of alcohol. And you saw opioid receptors in that sagittal section of the rat brain earlier. They're intermingled in there with GABA and nicotine and glutamate and everything else. And here we're dealing with something that deals with the NMDA receptors. And we know that glutamate is affected and NMDA receptors are affected. And I'm a huge fan of NMDA receptors. The neuroscience it's not a department, the neuroscience program just had a meeting of some faculty about what students should know when they graduate. And one thing that was specifically mentioned that neuroscience majors should know about is NMDA receptors. We were largely talking about learning then, not addiction, but they're important and prevents withdrawal, glutamate release, very important. Exciting new directions dealing with things that we've almost never dealt with before. CRF1 receptor antagonists, and that may help. But if you're administering it specifically into the central nucleus of the amygdala, that's a little hard to do in human. And as you see at the end of this, unfortunately, there have been few efforts to test CRF1 antagonists in humans because it's difficult to get it into the brain. And if you're only trying to get it into the amygdaloid receptors, we may have to wait until we develop something specifically only for them. And glucocorticoid receptor signaling, GR receptor. This looks a little bit better. No adverse effects reported for participants. Further investigation of GR antagonists for treatment of AUD is warranted. So that one's more hopeful. And this is clinical. And it's clinical using something called LY686017, which means it's still in development. It seems to reduce cravings and improve scores on general well-being when study participants were exposed to both stress and alcohol-related cues. That could be very important, very important. And since they're people, we can do fMRIs. Rats are too small for fMRIs right now. I think that's still true. So there's a nice discussion of that there. And I'm a huge fan of combining pharmacotherapy and talk therapy, particularly CBT, the therapy that works. Most effective treatments were medical management with either naltrexone or CBI with talk therapy. There's naltrexone again. It prolonged the time to first heavy drinking, which is really good. It's likely that alcohol dependence should be treated much like other chronic conditions such as diabetes and hypertension, where regular monitoring over time and rapid intervention with follow-up treatments as needed. Such monitoring and follow-up treatment should reduce the amount of healthcare needed to treat alcohol-related disease. By the way, diabetes. There was an in the news article today. You think about that as being straight clinical, but diabetes type 2, if you jump on it fast with aggressive dietary changes, you can sometimes stamp that out and you are no longer diabetic. Much preferable to taking drugs for the rest of your life. And we're done. And how's my time? My time is 4 minutes. Perfect. Okay, so I rushed a little bit. I'm a little bit sorry about that, but I don't think there's virtually nothing new in this chapter from a research perspective, research intervention perspective. The genetics and the behavioral tests and CBT, the idea that things are complicated and we have to attack problems from multiple directions. That's that's the way of the world, and we've already dealt with almost all those concepts. So thank you for your attention, and I will hit stop and hope I hear my voice right after it.